Hello everyone, this is Kalpana here. In this video, we're going to see a problem using the method of undetermined questions. So let's get going. Solve d square plus d plus 1 into y equal to x square using the method of undetermined questions. So we are given a differential equation d square plus d plus 1 into y equal to x square, right? Consider it as 1 and we can write it as d square y plus dy plus y equal to x square. Also we can write d square y as d square y by dx square and write this as dy by dx plus y equal to x square, right? We can write it as y double dash plus y dash plus y equal to x square. All these equations are same. Okay. So now consider this equation as equation 2. Given equation d square plus d plus 1 into y equal to x square, or we can write it as y double dash plus y plus y double dash plus y dash plus y equal to x square. We have considered it as equation number 2. Now we'll find the general solution to the given equation, which is given by y equal to yc plus yp, right? The given equation is in operator form, say f of d into y equal to some function of x, where f of d is d square plus d plus 1 and q of x is the RHS part of the equation x square, right? Now we'll find yc using the auxiliary equation and we'll find yp using formula. We can also find yp using a formula or a trial method. I'll pick trial method, okay? I'll give you the formula also. Fine, now let's go to let's begin with auxiliary equation. The auxiliary equation is f of m equal to 0, where f of m equal to, we have f of d equal to d square plus d plus 1, right? Let's replace the differential operator by m in f of d, so that we'll get f of m equal to m square plus m plus 1. Now the auxiliary equation becomes m square plus m plus 1 equal to 0. Now we need to find roots to this equation. Let's use quartic formula to find m. Just compare this equation with am square plus bm plus c, that is a quartic equation in terms of m, so that you'll get the values of a, b, c, where a equal to 1, b equal to 1, c equal to 1. Okay, quotient of m square a, which is 1, quotient of m b, which is 1, and constant c is 1. Right, now substitute the values in it. You'll get minus 1 plus or minus square root of 1 minus 4 into a into c by 2a, which gives us minus 1 plus or minus square root of 1 minus 4 by 2. Right, can also write it as minus 1 plus or minus square root of minus 3 by 2, or we can write square root of minus 3 as minus 1 into 3 by 2. Just split the square root as square root of minus 1 into square root of 3 by 2. Since we know that square root of minus 1 is I, so just replace square root of minus 1 by I, you'll get, right? And we can split it as minus 1 by 2 plus or minus I into root 3 by 2, a pair of complex conjugate roots. Therefore m equal to minus 1 by 2 plus or minus I into square root of root 3 by 2. Root 3 by 2, right? Fine. We know that when m equal to a plus or minus ib, yc looks like yc equal to e power ax into one constant cos bx plus another constant, say c2 sin bx, right? Now using this, we'll write a complementary function to our problem. yc equal to e power, just compare plus or minus, minus 1 by 2 plus or minus I root 3 by 2 with the formula. We'll get a equal to minus 1 by 2 into x plus c1 cos b equal to root 3 by 2 into x, or you can write it as x root 3 by 2 plus c2 sin x root 3 by 2, right? Fine. We got yc, which is equals to e power minus x by 2 into c1 cos x root 3 by 2 plus c2 sin x root 3 by 2. Therefore, yc equal to right? We got yc, now we need to find yp. We also have q of x equal to x square. Now compare the terms of yc and q of x. Here you are having e power minus x by 2 into cos x root 3 by 2 and e power minus x by 2 into sin x root 3 by 2. Okay, by neglecting the equations I am saying. Just neglect c1 and c2, then you'll have e power minus x by 2 x cos x root 3 by 2 and e power minus x by 2 sin x root 3 by 2 in yc, and q of x as x square, right? We don't have any common terms in these two, right? So you can say therefore q of x has no common term with yc, right? Fine. But we need to find yp. Yp must be a linear combination of q of x and all its linearly independent derivatives. Okay. Fine. So let's see the formula of yp. Okay. When q of x equal to x square, then yp will be, I am writing the direct formula, okay. Say a naught x square plus another quotient into x. If you have x square, derivative of x square will be 2x, right? Neglect the quotient and write x plus a2, another quotient. Derivative of x is 1, right? So instead of writing that 1, we'll just write a2. Okay, x square, its derivative gives x, its derivative gives a constant. Fine. Now, let's see the trial method. When q of x is x square, then yp must contain q of x, that is x square, and all its derivative. Let's find its derivatives now. Derivative of x square is 2x. Derivative of 2x is 2. Right? So here we'll write q of x and all its derivatives in one set. Okay? So it involves x square, x, and a constant. Right? Now using this, see, it involves q of x, which is x square, and its derivatives. Derivative of x square will give x, 1x, and a constant, right? Fine. Again, if you want to find derivative of 2, you'll get 0, right? 0. Fine. Now, we'll use this, or we'll use this set to find yp, a trial method. This is a trial method. We'll get x square, right? Yp involves x square with some quotient say a plus x with some quotient say b plus the constant. Write the constant as some c. Okay, already we have used a and b. Let's write it as c. See, you'll get the same formula. One constant into x square, one constant into x plus a constant. This is a bookish formula and this is a by trial method. Okay, always go for this instead of going with the direct formula. Okay, it is not that easy to remember the formula all the time. Right, now coming to yp, we got yp, so I'll go for it. Instead of taking a0, a1, a2, I'm comfortable with a, b and c, so I'm going for yp now. Let yp equal to ax square plus bx plus c. So we have picked a yp such that it satisfies the given differential equation, so that yp satisfies, right? We have picked yp such that it satisfies the given differential equation. That means we can write the differential equation in terms of yp. Okay, for that purpose only we have written the given equation in terms of y, so that it will be easy to change this equation in terms of yp when it's necessary. Fine. This equation was y, y dash and y double dash, right? Or we can just write the given differential equation as yp double dash plus yp dash plus yp, because we have picked yp such that it satisfies the given equation, right? It satisfies is nothing but we can just substitute, right? So here we are having yp dash and yp double dash, right? We need to find, already we have yp, but we need to find yp dash and yp double dash in order to substitute in the given equation. Right, now let's find yp dash equal to a into derivative of x square 2x plus b into derivative of x 1 plus derivative of constant 0, which gives us 2ax plus b, right? Now find yp double dash, which gives us 2a into derivative of x 1 plus derivative of a constant 0, which gives us 2a, right? Now we got yp dash and yp double dash. Let's substitute in it. One becomes yp double dash plus yp dash plus yp equal to x square. Now substitute yp dash and yp double dash. We'll get 2a plus yp dash 2ax plus b plus yp ax square plus bx plus c. Now simplify it. We'll get 2a plus 2ax plus b plus ax square plus bx plus c equal to x square. Now write x square term, or just take x square common, you'll get x square into a plus, now write the terms involving x, or take x common from these two terms, you'll get 2a plus b, and now take c, constants together, 2a, b and c, right? You'll get 2a plus b plus c equal to x square, right? Fine. Equating the coefficients of like terms. We'll get, now just equate the coefficient of x square, you'll get a equal to 1, right? Now equate the coefficients of x, 2a plus b equal to, you don't have any x term on RHS, so take it as 0. Now substitute the value of a in it, you'll get 2 into 1 plus b equal to 0, which gives us 2 plus b equal to 0. From this we'll get b equal to minus 2, right? Now consider the constants, equating the constants. We don't have any constant on RHS, so take 2a plus b plus c equal to 0. Now substitute the values of a and b, since a equal to 1 and b equal to minus 2, you'll get 2 into 1 plus b plus c equal to 0, you'll get 2 minus 2 plus c equal to 0, where c equal to 0. right? Therefore, a equal to 1, b equal to -2 and c equal to 0. Then yp becomes, since we have yp equal to x square plus bx plus c, substitute the values of unknowns here. A and b and c are undetermined equations. Already we got the values, so we'll just substitute in it. Okay, 1 into x square would be into x plus c, which gives us x square minus 2x. Therefore, yp equal to x square minus 2x. See, we got yp and yc. Let's now write the general solution to the given equation. Therefore, the general solution to the given equation is given by y equal to yc plus yp. Then y equal to yc, you have e power minus x by 2 into c1 cos x root 3 by 2 plus c2 sine x root 3 by 2 plus yp plus x square minus 2x, which completes the problem. Okay, you can also check or verify yp using 1 by f of d into q of x. You can verify yp using this formula. Well, we have seen a problem using method of undetermined coefficients in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.